Hi everyone, this is Yingfei Shen, and my topic for the final project for data engineering and mining course is Home Depot product search relevance. As many of us may have shopped in the Home Depot for family house improvement, buying household appliance, or maintaining beautiful gardens, one of the pain points when shopping in a giant warehouse-like store is that we can't find the most relevant product as we want. And we always need to rely on the experienced store assistants to give us the advice for latest and most suitable products. To avoid this dilemma, Home Depot hosted a Kaggle competition asking for an advanced model that can predict the relevance of customers' search term and their products so that Home Depot can improve their customers' help yourself shopping experience and no longer need to rely heavily on the store assistants. So I started the project by understanding the data. The data set is a combination of product information and real customer search terms derived from Home Depot websites. The Home Depot also provided a training set which contains product information, search terms, and corresponding relevance scores, which is the average score rated by at least 3 human raters. Therefore, the relevance score can be a decimal between 1 and 3, where 1 means the least relevant and 3 means most relevant. So let's look at the data sets. So the training data sets, as is here, the train CSV, has the following attributes. It has ID, which is an identifier of each row in training data set, and product UID, which is integer, stands for the unique identifier of the product, and product title, which is a text-like string, is the title of each product, which might have typo and special symbols in it. And search term is the customer's search input. It has less unique values than the product title, so it may contain duplicative values. And relevance, as I mentioned, is a decimal between 1 and 3. The higher the value is, the more relevant between the search term and the product. So this is a basic stats about train. We can see like there is the mean relevance is 2.42 and standard deviation is around 0.5 and minimum and maximum here. And the testing data set has the same attributes except that it's missing the search relevance, which is the prediction we need to make. And the other source data is production and description. As we can see here, it has product UID, which can be linked with the training or test data sets and it has further product description. It is a long description of the product and might contain some HTML or other format content. And we also have another source data called attribute.csv, and it contains detailed technical specification by specifying the attributes name and value. It has the following attributes like, once again, product UID can be linked to the training and test data sets, and the name of the attributes and the value of attributes. Many of them, the name does not mean much, like bullet 1, 2, 3, 4, 5, but some of them may have like brand name, color, or material, something would make sense. So after knowing the basics of the data, we're ready for the data preparation. As all of the data sets are extracted from Home Depot web database, which are mostly manually entered, there are numerous typos, sentence-like information that contain irrelevant stop words. Therefore, one important step in the data preparation is data cleaning and stemming. I first concat the training datasets with the testing datasets to become a defined data frame all. And from observing the search terms, I captured some attributes type that customers are likely to put in search term, such as brand, color, and material. So I extracted the attributes type that customers are likely to put into the search term from the attributes.csv into the large data frame. According to the UID, so I append as a additional column for brand, color, and material. And then after the above operation, I got the following data sets for data cleaning. You can see I have the following columns. So as I mentioned before, not every product will have certain attributes. So we can see that many of the attributes are shown as not available. So the first step of the data preparation is to place the NaN with something readable. So as some of the columns such as products, so here I replace the NaN, and if it's an integer, then I fill with 0. If not, I just fill with space. So as the some of the columns such as product title and product description might contain sentences, the next step of data preparation is to remove the stop words that have no value for relevance prediction. I utilize the Python package of sorry, this is another functions I'm using. I'm just gonna jump into this methods of removing stop words, punctuation, and eliminating the words first. So I utilize the package of nltk.corpus, which prepare us with the common English stop words such as I, you, he, she, am, or is, because, up. That's like contained in the sentence but does not make sense for keywords. So I also removed punctuations by using the Python package string to make the text more like keywords. I did a lemmatization to get rid of the tense in all the text columns by using the WordNet lemmatizer function from the NLTK stem package. Finally, the process keywords might have different expression when trying to say the same thing. For example, like if we are trying to say the air conditioner, we might say AC, A/C, or something else. So I just replace the expression like similar to each other to a uniform expression. Yeah, so I wrote this customized functions to automatically correct the different expressions, and I uniform the measurements like inches convert to inch, something like that, to make better accuracy when making the predictions. So besides the existing features, I'm also trying to create new features. The first of them is like here I'm trying to convert the information from text to vector and compare the similarity between the vector of features to the vector of searching terms. So I applied the cosine similarity of product title, product description, brand, material towards the search term. Thus, I can create 4 new features. Namely, it's called cosign title, cosign description, cosign brand, and cosign material. And I also try to create a new feature that's how many common words between the search term and the descriptive attributes. It's like here, that so that they can emphasize the accuracy of the prediction. At this point, I have the comment in title, which is the common words, number of common words between the search term and product title. Similarly, like between search term and product description, I have comments in description and comments in brand, comments in color, and comments in material. So at this point, the raw input of title, description, and attributes are not important anymore. So I just drop these row columns, and then what's left is all integer base. I have the cosine similarity between the attributes and the search term, and the common number of common words between the descriptions and the search terms. And I kept the relevance for the training data sets. So after doing all the data cleaning and feature engineering, I again separate the large data set into the training and testing data set again. So here we can see like the relevance of training is still its original number, and the testing is keep the relevance as 0. So next part is our modeling part. Oh wait, before the modeling part, I just dropped the relevance to keep the tests as original. And as the goal of the project is to predict the relevance value, which is continuous number between 1 and 3. So for the modeling part, the most natural approach for me is to fit the training data sets into a regression model, and the to get the training features rather than the classification or clustering. So I decided to use the following regression. I applied linear regression and random forest regressioner, and especially I pay attention to like when the prediction of y is larger than 3 according to some linear models. I'll just transform it as to 3 to avoid some like error noise or error will occur. And I also applied some support vector regression and gradient boosting regressor and XGB regressor, and the K-neighbors regression and SGD regression, and I'm combining in the XGB boosting regression and bagging. So I use the root mean square error for evaluating the accuracy of the models. The algorithm with the smallest RMSE is the most suitable model. So actually in this specific project, because it's a Kaggle competition hosted by Home Depot, it provides some submission portal for us to I can just provide each records ID, and the prevalence I predicted to a CSV and submit to the competition so that I can get the public RMSE as well as private RMSE to get the most accurate accuracy for each model. So for the models I applied, as we can see, the most accurate model is by using support vector regression. So I decided to use this algorithm as my deployment, as it's C equals 1 and epsilon equals 0.2. So what I learned from this project is like it is very important to clean the dataset to improve the accuracy of the algorithm, and not all features from this source data are useful for predicting the relevance of the search terms with the products, and extracting the useful insights and drop the irrelevant features can largely help to get better accuracy. And converting the text-based feature to vectors can have better performance and helps a lot in comparing the similarity between the texts. And I also learned a lot in natural language processing, like stemming, lemmatization, and remove punctuation. All of these are very practical techniques. And I learned like the support vector regression, why it works the best for the prediction in this case, because it works well because it's good at predicting continuous values, and in contrast to the traditional linear regression, it is trying to fit the error within a certain threshold instead of minimizing the error. So by deciding a decision boundary, we can avoid the problem of overfitting, which will decrease the actual RMSE when applying the algorithm to the test database. All right, that's it for my final projects walkthrough. Thank you so much, everyone.